Question number 7 on the review. It says solve for x. It says x plus 2 divided by 2 equals 3x minus 4 divided by 5. What I was talking about with my class yesterday was the fact that if you look at x plus 2 divided by 2, there's another way you can actually interpret that. And it's saying if this is x plus 2, that's x plus 2, this here means that I have half as much as that. I don't have that. I have half that. Whatever this value is, x plus 2, I have half as much of x plus 2. And over here, if I look at this one, I have 3x, very well drawn, minus 4. I have a fifth of that. I don't have a full 3x minus 4. I have a fifth of that. So what we're really going to do here is we're going to realize that what I'm going to do is I don't want to work with fractions. It doesn't work very well in algebra. Well, you can, but sometimes it's harder. So what I'm really going to do is I'm going to find a common multiple of the denominators, because I know if I multiply a fraction by a multiple of its denominator, I'm going to create a whole number. So again, thinking about that, if I was to multiply x plus 2 by 2, again, half of x plus 2, but I doubled it. If I had half of x plus 2 and doubled it, I would have a full x plus 2. The only problem is keeping this idea of balance in mind. If you double this side, you have to double this side in order to keep it equal. So by doubling this side, if I only have a fifth of it and I double it, that's not going to get rid of the fraction. That's only going to make the fraction more complex. So I don't want to do that. I'm not going to multiply by 2. What I'm going to multiply, however, by is this number here, the first multiple that 2 and 5 share, in this case 10. So I'm going to multiply this side by 10, and I'm going to multiply this side by 10. I'll get rid of this here. So if you get rid of that, now think about this. If I have half of x plus 2, but I have 10 of those. So again, thinking about that scale, I'm taking this side and multiplying it 10 times greater than it was. And over here, I'm going to multiply this 10 times greater than it was. If I have half of x plus 2, but I have 10 times more than that, I'm actually going to have 5 x plus 2s. Now I cross-reduce there just to show you. I'm going to have 5 of these. So 5 x plus 2s. Right, if I have 10 altogether, I'm going to have 5 of them. And over here, if I have a fifth of 3x minus 4, but I multiply it by 10, I'm really going to have 2 full groups of 3x minus 4, or 2 groups of 3x minus 4. Okay? So by multiplying both sides of that original equation by 10, I create this new one that is devoid of fractions. I then have to then use distributive property to simplify this side. I get 5x plus 10 is equal to 6x minus 8. There's the expanded form of that equation. I then notice that I have variables on both sides. Now there's a whole bunch of different things you can do. Now if you have good algebra sense, there's a whole bunch of different ways you can tackle it. You could subtract 10 from both sides first, that will work. You can add 8 to both sides, that will work. But the best thing you can do first when you have two algebraic expressions on two sides of an equal sign is simply create a zero pair. I'm going to actually just subtract or take away 5 x's from both sides. And again, thinking of that, let's see if I can get my eraser here. Thinking of that from a modeled perspective, if I had 5 x's on this side and 10, which is going to be a lot, and I have 6 x's on this side and minus 8, if I was to take away, I'll have to use a smaller brush because I'm going to destroy it. If I was to take away 6 x's on this side, oh sorry, oops, I'll reverse that. If I was to take away 5 x's from both sides, take away 5 x's from here, but do the same thing over here, take away 5 x's over here, that's still going to keep this thing balanced or equal. As I destroy my fulcrum, it's now equal. Algebraically speaking, subtracting 5 x's here creates that zero pair. It's gone. I'm left with 10 on this side. And over here, I had 6 x's, but I took away 5 x's from that side. I have an x left, minus 8. Now this is a very simple algebraic equation that's now down to. All I have to do is get rid of the constant by adding 8. And I end up with x, zero pair by the way, x equals 18. So that's the solution. Now if I go back and substitute it, you should be able to figure out that that was indeed the solution to the equation.